Hey guys, how's it going? We're going to go through 4.5 day 2. So we worked on 4.5, which was graphing sine and cosine functions. Today we're going to continue that, except now we're going to throw in some shifting. So horizontal and vertical shifting. Some of this may look a little familiar because in reality there's not much difference with shifting these graphs as opposed to shifting a linear or a quadratic or any of the other transformation, those parent functions that we were transforming in chapter 1. The only thing is, honestly, the hardest part is probably labeling your x-axis after you're shifting, right? We have like those 5 key points, your start point, your stop point, which is like one cycle or one period's worth of your sine or cosine graph, and then dividing that into 4 sections. So it gives you a total of 5 key points. That's probably the hardest part. The rest of it is basically the same. So we have a little more complicated version of our sine and cosine equation. So I think before we just had a times sine of bx or a times cosine of bx. Now we have this minus c after x inside the parentheses, and then we have plus d on the outside. Okay, and that's going to be where we'll find information about our shifting. Inside is going to represent horizontal shifting information, and then on the outside, plus d, plus or minus d, is going to represent our vertical shifting. So just a refresher, amplitude is still going to be the absolute value of a, so your coefficient on your trig function. Your period is going to be the value that you get when you do 2 pi over b, or 2 pi over the absolute value of b. It should always be a positive number here. So the 2 new pieces, your vertical shift is either up or down d units. So if you're adding a d value, it's going to shift up. If you're subtracting, it's going to shift down. And then this might look a little bit different than what we've done with other functions, but that value inside the parentheses that includes x, so bx minus c, that could be a plus sign as well. It just means that c would be negative. Either way, we're going to set that entire parentheses equal to 0, solve for x, solve for your variable, and then it's either going to be a shift to the right. If it's positive, if x equals a positive number, it's shifting that many units right. If x is negative, it means we're shifting that many units to the left. Okay, and then the other piece that we broke down with our non-shifting graphs from the other day, to get those 5 key points, you're going to add from your first x-axis value where your graph starts, you're going to add a value of your period divided by 4, and that's going to ensure that by the time you get to that last point, you've gone an entire period. Okay, so feel free to pause and get that down, and then we're going to do 2 examples, and then you'll be practicing graphs with non-shifting and then with shifting. Okay, so for example 1, we have y equals the sine of x minus pi over 3 plus 2. So what I'm going to do, let me zoom in here. I'm going to say, all right, here's where my a value is, here's my b value, c value, and d value. So it's really 1 times the sine, and then inside the parentheses it's 1x. So my amplitude is the absolute value of a, which is just 1. My period is going to be 2 pi over b, absolute value of b, which is 2 pi over 1, which is just 2 pi. All right, so there's my amplitude. There is my period. Shifting, plus 2 indicates I'm going to go up 2. And then for the horizontal shifting, I'm going to put a comma here because I am going to have a horizontal shift. I'm going to take this entire set of parentheses. So HS means horizontal shift. X minus pi over 3, set it equal to 0, solve for x. So adding that fraction, we get pi over 3. That means since it's positive, I'm going to shift to the right pi over 3. And then to find my key points along the x-axis, I want to add from my first value, let's see, it's my period over 4 So that's 2 pi over 4, which is pi over 2. Okay, so let's draw in the shifts on the graph. So typically, let's see, sine would normally start right there, right at the origin, but I know I need to shift right pi over 3. So instead of starting there, let's shift to the right. We'll call this pi over 3. And then I want to go up 2. So up 2. Okay, we'll call that 2. So my midline, which is typically the x-axis, has now been shifted up 2 units to a y value of 2. All right, so now instead of starting here, I've shifted right and up, and I'm now going to be starting my graph where those 2 dotted lines meet. So here's how I would approach this. There's a few ways for how to graph this, but what I like to do is, before anything else, we can kind of sketch what this graph is going to look like, right? So let's take care of the amplitude. So I know I'm going to go from my midline up and down 1, which is going to be a max of 3 and a minimum of 1. This is a sine graph that is not going to be reflected because it's positive. So let's see, this was pi over 3. I know, let's call that my last point, so that'll be pi over 3 plus that 2 pi. Now I'm going to split this into 4 sections. So let's cut this in half to get 2 sections, and then each of those smaller pieces I'll cut in half. So let's sketch what this is going to look like. Instead of starting at the origin, we said that I would start where these 2 shifting lines meet. And then sine graph, usually I go up first and then down and then come back to the midline. So we'll do that same thing. I'm going to go up first, then I'll come back to midline, then I'll go down to the minimum, and then up to the midline. So sketching. And of course, this will continue before and after. So there's my graph. Now to really the hardest part, and this is really important, we want to be able to figure out the values that we're placing at each of these key points on our x-axis. So here's, in my opinion, the easiest way to do this. Let's come back, and from this first starting x value and the value that I'm going to be adding, let's find common denominators for each of those. So pi over 3 and pi over 2. Let's see, 3 times 2 is 6. So those need to both be over 6 if I'm going to be adding that value every time. So pi over 3, I'm going to write as 2 pi over 6. Same value, right? That's that first marker. Pi over 2, I'm going to change to 3 pi over 6. Same value, right? That's what I'm going to be adding every time. So every one of these markers, I'll add 3 pi to the numerator. So this would be 5 pi over 6, 8 pi over 6. Yes, I could reduce it. Not necessary though. 11 pi over 6, and 14 pi over 6. So we're basically done. What I want to do now is just verify my period should be 2 pi, which means from the start to the end of that cycle, it should be 2 pi. Well, I go from 2 pi to 14 pi over 6, so that's 12 pi over 6. Yeah, that is 2 pi. That's a distance of 2 pi units, which is our period. So that's a really good check to see if you spaced out your x-axis correctly. Okay, next one. Example 2, we have y equals negative 3 cosine, and I got a lot of stuff going on inside, 2 pi x plus 4 pi. All right, let's kind of go through the same process. So the amplitude is going to be the absolute value of negative 3, which is 3. The period is going to be 2 pi over b, which is, maybe I should do this. Here's my A value. Here's my B. Oh, so 2 pi is my B value. Here's C, and here's D outside. So 2 pi over B is really 2 pi over 2 pi, which is 1. Okay. Shifting, there's no value being added outside in place of the D, so that'll be no vertical, but horizontal shift, take 2 pi x plus 4 pi, set it equal to 0, subtract 4 pi, remember I'm solving for x, divide by 2 pi, I get x equals -4 over 2 or -2. Okay, so x is -2, negative meaning I will shift left 2. And then to find the other key points, I'm going to take my period divided by 4, which is 1 over 4. Okay, so on my graph here, let's see, no up or down, so that's kind of nice. I am going left 2. All right. Let's see, my period is 1, which means I'm only going to move to the right 1 unit from that starting point by the time my graph finishes. So it's going to go to -1. Ooh, this is going to be a really small graph here. So this is like where my graph ends right here. So let's see. Start here, end here. There's half. Now cut each of these two in half. There's my 4 different sections. So my amplitude was 3. So there's 3 and -3 for my max and min. And let's see, this is a cosine graph, which means I would start at my max. Ooh, but this is negative, so I'm going to reflect over the x-axis. I'm going to start at the minimum. So I start at -3. Then I hit the midline. Then I hit the max. Then the midline. Then the minimum. Okay, so this is going to be skinny. All right, there's my graph. And last part, we said the trickiest part sometimes is getting the starting point and this value you're adding to have the same denominator. So denominator of 4, I think I can just call -2 is really -8 over 4, which means this would be -7 over 4, -6 over 4, -5 over 4, and -4 over 4. Which is really -1. So I'm going from -2 to -1. Well, that makes sense because that's a distance of 1. So kind of like we did on the last one, this distance here is 1 unit, which is our period. Okay, so that's a tricky one. Just I think because you're fitting in such a small space, but we can manage that. And then yeah, that's all we have. So we'll do a couple practice ones. I think there's 6 problems on the practice, 2 of them with no shifting and 4 of them with shifting. So all right, guys, thanks for tuning in. Take care.